Hey guys, 3.4 here. Graphing linear equations in standard form. And we're going to start with kind of the easier ones, the horizontal and vertical lines, right? Horizontal lines, these lines that go side to side, right? Maybe we should draw, underline and arrow it to this one. Have an equation of y equals some kind of number, right? And vertical lines, so maybe I'll put a circle around this and point this over here because vertical is the one that are up and down. They have this equation of x equals a number, and they're calling it a, but it really just stands for a number. So the easiest way for me to tell you how to do these is to look at, so first of all, we're going to graph a here, we're going to graph y equals 4. We're going to graph b here, we're going to graph x equals -2. Is to look, where does y equal 4, right? And I'll give you a hint that says x right here, and it says y right here. So y equals 4 right here. But guess what? Where else does y equal 4? Does y equal 4 here? No, that's x equals 4. Does y equal 4 here? No, that's y equals 3. But y equals 4 right here, right? That's the point 5, 4. This is the point -3, 4. So y equals 4 everywhere on that line, and that's how we know that it is a horizontal line and not a vertical line. Whereas with x equals -2 right here. Again, on the x-axis, -2 is right here. It's not going to be a line like this straight through this way, because right there, x does not equal -2, it equals 1. Where else does x equal -2? Well, right here at -2, 2, at -2, -4 down here. Everywhere on that line tells you, oh, it's a vertical line. Okay, it's a vertical line because it's x goes through the x. In fact, I want to write that down. X goes through, capital letters, x-axis. Y goes through y-axis. Right? So y equals went through the y-axis. X equals goes through the x-axis. And then we talk about domain and range of these because we've seen enough of this already anyway. The domain of this is the x values, and the x values keep going left and keep going right. So if you remember, we said that was all real numbers. Okay, if you want to write all real numbers, write it. The range is literally, remember we said y equals 4 here, y equals 4 here, it's just y equals 4 because it's everywhere y is. Same thing over here. The domain, well, the domain is just x equals -2, and the range keeps going in every direction, and that's all real numbers, okay? I don't need you to do the domain and range on these problems. I'm just kind of trying to make sure that I talk about it. So pause the video a second, look at what we did on those first two examples, and try number 1 and 2. All right, so where does y equal -2.5? Well, y-axis, -1, -2.5 is right about there. And it goes through the y, not this way through the x, so I'm just going to draw my line straight through there, right? 3, -2.5. It all works out. Now my domain here, again, you don't have to do this, is all real numbers. And my range is just y equals -2.5. For x equals 5 right here, and right here, and right here, and so on. So it is a vertical line, like so, right? That's it. That's x equals 5. And then I've got my domain here is just x equals 5, and my range is all real numbers. That's how these work, okay? All right, cool. Let's go to the next page then and check out how we can solve for x-intercepts when they are in this standard form. You don't know this, but standard form is ax plus by equals c. That is standard form. And it's giving us equations in that form all the way through this whole page and even onto the next page, right? So to find the x-intercept when they're in this, it's where y equals 0. That's kind of a big deal, where y equals 0, which means that it's got to be the x-intercept. It's got to be somewhere on this x-axis. And the y-intercept has to be on this y-axis, and that's when x equals 0. So when x equals 0, it kind of eliminates that term, and you would just solve that, right? So what I'm trying to say here is, to find the x-intercept, let y equal 0 and solve for x. What does that mean? That means just set, can't write, the x term equal to 0. And for this one, it says set the y term equal to 0. So here's what I'm saying here. To find, let's write this down. I've got my x-intercept. I'm looking at example A here. And I've got my y-intercept. Okay? So for the x-intercept, let y equal 0, which means if I plug in 0 here, it goes away. And so really what I'm doing is setting the x term equal to 0. So x equal to 0, equal to the number. I'm sorry, replace that, put number. It's equal to the number. Maybe that even doesn't make sense, but let's actually look at an example. If I plug 0 in here, it goes away because 4 times 0 is 0, and I would just have 3x equals 12. So for the x-intercept, set the x term equal to the number on the other side. For the y-intercept, we're letting x equal 0. So I'm going to put 0 in here. That goes away. And I've got to solve that then. I've got the y term for y equals 12, and I just go about it that way. So on these two problems here, how do I solve this? Well, I would just divide, and I get x equals 4. And right here, I would just divide, and I get y equals 3. So if I were to go and graph these, y equals 1, 2, 3 would be right here. X equals 1, 2, 3, 4 would be right here. And that would be my line. It's that easy. Okay? I'm going to have you guys try B and this B in just a minute. I'm going to come down here and try this one. So again, for my x-int and my y-int, again, these stands for x-intercepts and y-intercepts. For the x, I would set the x equal to the number. So I've got negative x equals 16. Again, I call it the cover-up method, right? Maybe we should write that down. Cover-up method. That's how I refer to it in class. I'm going to cover up the y and solve for x. So I get negative x equals 16, right? I'm going to cover up the x. I'm going to solve for y. So I get negative 4y equals 16. And that is how I solve the y. It's just set the y term equal to the number, set the x term equal to the number. Now this really means negative 1, so I would divide, and I get x equals negative 16. Here I would divide, just like I've been doing, and y equals negative 4. So again, if I were to graph this, y equals negative 4 is like right here, but x equals negative 16 is going to be way, I probably have to keep my graph going, out here. And I probably have to go by 2's when I see something like that. And we might see something like that coming up. Press the video, press pause on the video, go try B and this B, and use the cover-up method and find your x and y intercept. All right, so the x term is 2x, set it equal to the number. The y term, again, if I cover this one up, is a negative y, right? Negative y equals 4. Divide by 2 to get x equals 2. Divide by negative 1, because that's really a negative right there, to get y equals negative 4. And I've got my answers, done. This really gives me, and I haven't been saying this, but this point right here is the point 4, comma 0. That's what this means, right? This is the point 0, comma 3. Again, because the x was 0, I plugged in 0, I get the other value. So this means 2, 0. This means 0, negative 4. So again, when I go to graph that, 2 zeros right here, 0, negative 4 is here, boom, there's your line. Okay. Next one, 5x equals negative 30, and negative 2y equals negative 30, and I would divide both of them to get x equals negative 6, and I'd divide both of them here, and to get y equals 15. And again, if I'm looking at a graph, this is negative 6, 0, and this is 0, 15, and I would just go graph those points, and I probably have to go by 2's on my graph. Which is funny I would say that, because on the next page, we do have to graph it. Let's flip it over to the next page. And to graph these equations, really, I just want to do the same thing that I've been doing. I want to find my x and y intercepts. So I'm not going to do this one, I'm going to have you guys do this one. But if I find my x-int, and I find my y-int, then I can solve this. So what do I mean? Let's do B together here. So to find my x-int, I set the x term, 2x, equal to the number, 4, just like we were doing on the previous page, right? For the y-int, again, I would set my y term, which is negative y, equal to the number. And again, for both of these, I would just divide. I get x equals 2. Where does x equal 2? Right here. That gives me the point 2, 0, right? Here I would, again, divide by a negative 1, because when there's nothing there, it really means that. And I get y to be negative 4, which again means 0, negative 4. So where am I plugging that? Well, 0, negative 4. Where does y equal negative 4? Right here. and boom, we're all done. That's it, that's the graph, okay? We're gonna try, I'm gonna have you guys do A and B, but I want you to see something here that's a little different. So again, when I set for my x int, I get 5x equals negative 30. For my y int, I get negative 2y equals negative 30. If this looks familiar, it's because we just got done with a problem like this, and I did actually explain it. I get negative 6. Where does x equal negative 6? Well, we'll get to that. I guess maybe let's do this first. Because look what happened. I get a big number, 15. Right, again, this is giving me negative 6, 0, and 0, 15. But 0, 15 isn't going to fit. This is going by ones, then that's 10 right there. So I'm going to go by twos in both directions, okay? So by twos means that this is like 10, that this is 10, this is negative 10, and this is negative 10. So negative 6, 0 would be 2, 4, 6, right there. That's negative 6, 0. And 0, 15 is going to be way up here. Here's 10, 12, 14, 16. So 15 is right there in between them, right? That is 0, 15. And then okay, I kind of missed my dot here, but you get the idea here. Okay, I connect my dots, got my graph done. That's the problem. So if you get a number when you solve these that's over 10, then you probably want to go by twos on your graph, or maybe bigger, but I'm probably not going to do too many more difficult than that. So let's try both A's on the other one, and I'm going to tell you right now, one's going to go by ones and one's going to go by twos. So solve for your x and y intercepts first, and then determine what do I need to go up by in my graphs to make it fit. All right, press pause, try it out. For the first one, the x-intercept I set equal, and the y-intercept I set equal. And I divide both sides by 3 here to get x equals 4. I divide both sides by 4 here to get y equals 3. Both of those are going to fit on this graph. X equals 4, boom, right there. Y equals 3, boom, right there. Connect my dots. Okay. On the second one, again, I'm going to have my x int and my y int. So for my x, I've got negative x equals 16. For my y, I got negative 4y equals 16. Again, if I see minus signs, they're negatives. That really means that. So I'm going to have x equals negative 16, which already tells me this graph has to go by twos. Right now, I'm going to divide that by negative 4 and get y to be negative 4. This does not mean negative 16, negative 4 is my point. It means negative 16, 0, and 0, negative 4. Again, I'm going to make this go by twos. So for 0, negative 16, 0, 2, 4, 6, 8, 10, 12, 14, 16. It's way over here. And then 0, negative 4 is down 2, 4, right there. And then finally I get 2 points that connect as well as they should. Okay, so that's it. That's how you graph those. We know how to find these by just setting the x and the y equal to the number and dividing them. You get those numbers, plot them on the x-axis, plot it on the y-axis, connect your dots, done. Okay, and that gets you to what the homework is for today. Okay, so the first few are just horizontal and vertical lines. Look at what we did. I talked about domain and range on the notes, so you should be able to fill that in. And then what makes it a function, remember, is if it passes the vertical line test. Okay, for these problems, you're just going to plug and find the x and y intercepts. The first one is actually done for you, but maybe you literally just want to do it like we learned how to do it. The x-intercept, the y-intercept, and then you set each of those terms. So 5x equals 15, solve it. Negative y equals 15. Remember that means negative 1. And solve both of those to get your answer, and then try number 9 on your own. Okay? This is one that I really want you to think about, number 14, before I just start giving you answers on that. So I'm not going to go through it. On the back side, it says find the x and y intercepts and graph. Right? So that's pretty simple. You're just going to do your 3x equals 6 and your 2y equals 6, and you divide to get x equals 2, and you divide to get y equals 3, and you go plot x equals 2 and y equals 3, and boom, connect your dots. That's all it is for these top problems, okay? For all of the top 6 problems. And then at the very bottom, it's just, hey, look at it. Can you identify the x and y intercepts? Right? There's an x-intercept. Write that point here, negative 2, 0. There's a y-intercept. Write that point here, 0, 3. The domain, well, when they are these lines, guys, these lines that keep going up and keep going down and keep going right and keep going left, it's all real numbers for both the domain and the range. And you can either write all real numbers or that funky symbol that we learned, okay? That's it, just 2 pages here. Get through that. Have a good day.